All right, I've got another one of these decomposition problems. In this case, I have a vector f. There it is, vector f. And I want to put it into components in the e hat 1 and e hat 2 directions. And those directions are defined like so. So again, what I do is I form this vector triangle. F is the hypotenuse of that triangle. And the other two sides of the triangle are vectors that are parallel to the e hat 1 and e hat 2 directions. So in this case, I've started at the tail of f. I go up in the e hat 2 direction, and then I move over in the minus e hat 1 direction, and these two vectors are ordered tip to tail so that when I add them together I get the original vector f. And then I notice that I've defined an angle theta here so that f is oriented an angle theta away from the positive vertical, and it's not too hard to see that that corresponds to this angle right here in my forced triangle. So therefore, let's look at the pieces. So in the e hat 1 direction, here's the e hat 1 direction. That's the side there. This is the component which is opposite to this angle theta in the right triangle. So that's why its magnitude is f times sine theta. Right? Sine theta corresponds to the opposite. And this component in e hat 2 direction, this is the adjacent side. So therefore, I have a cosine theta. Again, looking at pluses and minuses in this thing. Look at the e hat 1 component. That's towards the right, but the e hat 1 basis vector is to the left. So these are in the opposite direction. So I need a minus sign right there to make that work out. Whereas the e hat 2 component of the vector f is in the same direction as the e hat 2 vector, or basis vector. So therefore, we've got a plus. So both these are the same sign. All right, so that's it. What I'm going to do is place a box around the answer. And I think I'm happy.